No, your eyes do not deceive you. It is the return of the most boring man on YouTube. My name is Carl. Welcome to my workshop and welcome to my YouTube channel. What we're going to do today is have a bit of an update on what's been going on with the mill and what's been going on with projects in the workshop in general. So you're probably wondering what's been going on and why the long absence. Now, as you know, my wife was ill. She had breast cancer and she is now doing a lot better. The radiotherapy that she had last summer worked really well and she is well on the mend now. So I've been trying to get back to some kind of normality in the workshop. Now, you're probably wondering what's going on with the gas turbine project. Well, I've had to shelve the gas turbine project for the time being, and the reason I've decided to do that is because I'm literally tripping over milling machine parts in this workshop. It's not particularly big, and you'll probably see a little bit more of that in a minute because I intend to show you around a little bit as I'm showing you the milling machine parts. And so I've decided to get the time that I have got in here concentrated on finishing the milling machine and getting that done so that I can get some more space in here and I can then move on to doing better projects or more interesting projects from the point of view of building the gas turbine and that type of thing. I'm just really stuck for space in here and that is my biggest issue. So without further ado, now I'll show you around a little bit and I'll show you some of the things I've been up to. So we're handheld now and I'm showing you the main base and body of the mill, the column. Now, I think you probably will have seen this because I did put some postings up of me stripping the paint from the body and the base. Stripping paint off something using an angle grinder with a wire wheel on it is not the sexiest job in the world, so I didn't make a film about it. However, you can see what the actual outcome of that was. So all the old horrible hammerite is now off the machine. And there's the weapon of choice, angle grinder with a cut wire wheel on it. But you can see what's happened here in places. Some of the filler's been knocked out. And you can see some of the filler here and down there. And you can see, again, some areas where the filler's been knocked out by the cut wire wheel. So that will have to be filled before I can, and smoothed out before I can paint this again. And this filler here is showing some scuff marks from the wire wheel. So I'll have to just go over that with fresh filler and just sand everything down, make sure it's nice and smooth before I paint it. You'll also remember, or you may have seen on the postings that I cleaned the inside of here out, which was the coolant sump. That's all nice and clean now in there. And I did have to write to the Natural History Museum because there were several species living in there that were previously unknown to science, so they have now been logged. I've added my my contribution to botany and zoology. So you can see down there, look, this is an example of, you know, the kind of issue I've got with storing components from the milling machine. Those boxes there do not contain chicken tikka masala. They actually are all the parts, all the piece parts from various assemblies on the machine that have been cleaned up and are ready to be reassembled when the time comes. One of the things that I've had to do with a lot of these smaller components is obviously paint strip them as well. And the way I've been doing that is, I'll just quickly show you in there. There's not vanilla in here. There is in fact some parts, some panels and some parts of the coolant system that you can see are being paint stripped. The way I've done that is to use what's in that container there, or that spray bottle, which is actually a proprietary parts cleaner, which is actually isopropyl alcohol combined with some toluene. So that lifts the hammerite off these components without any issue whatsoever. One of the things that I have been thinking about is the base of the machine is actually the color that it was originally and was supposed to be. I'm just really thinking of just keying that up and painting over it, because I can't really see the point in stripping all of that. Obviously the bottom has been floor painted. They must have painted the floor wherever this machine was sitting at some point, and it's got floor paint around it, so I'll have to do something with that. But let me know what you think about that anyway. I mean, I can easily strip that base, but is it really worth it? I don't know. And the old machine moving system, patented Wilson machine moving apparatus, has been well to the fore, because obviously I'm not going to be paint stripping the mill in here because it's just too messy. Through that door there outside to the hard standing area that I've got, and that's where I've been doing it. So I had a few problems recently with the weather. It's been very cold here and there's been a lot of snow on the ground, which has hampered my ability to get outside and paint strip. The next thing that needs to be stripped is the knee, which shouldn't take too long, to be fair, with the cut wire wheel. So that's the next thing that needs to be done, and I need to clean all the ways up on the knee and on the column as well. They're just temporarily masked off now, and the only thing they'll be getting is just some Scotch-Brite and then stoned afterwards, just to make sure that they're okay. No scraping. Behave yourselves. I'm not going to start scraping this. I haven't got a clue how to do it for a start. Right, so what we'll have a look at now is some of the piece parts and some of the problems that I've been having with them, and one particular issue that's been thrown up. Okay, so let's get fired right into this straight away. What we're looking at here is the illustrated parts drawing for the knee bracket assembly, and the thing I want to show you is this component here, which is the cross-slide lead screw. And I had an issue with that, which I'll show you in a minute. The nut was very worn, and I managed to get a very excellent replacement part, a brand new, or a new old stock one, and I'll show you that now. I like using the drawing because I want these videos to become a bit of a repository of information on these mills, so using all the approved documentation I think is always a good way forward. So this is the part I was just showing you. This is the saddle lead screw and nut as I remove them from the machine. Now this is 5/8 10 TPI Acme left hand, and as you can see there's quite a lot of wear. If I bring it a bit closer you can probably see better. Quite a lot of slop in that, which I wasn't happy about at all. And my original plan was to get myself a piece of bronze and make a new nut, as I did for this one here that you can see that's for the knee lead screw. You'll remember when we made that. Now I was finding it quite hard to source a piece of square bronze of the right dimensions to make this nut, because I didn't want to. I could easily get round, but I just considered it really wasteful to mill a square block out of a piece of round round bronze. I mean, I could have had a more of a radius in it and altered it slightly, but yeah, it still would have been a waste. But while I was looking for some bronze on a well-known internet auction site, I came across a new old stock component. So this is a complete assembly, the lead screw and the nut, and it's absolutely bob on. There is no play in that whatsoever, and that's a really good find. The best thing about it was I'd actually managed to find a piece of bronze of the correct size that I needed, and this whole assembly was cheaper than buying the bronze. So actually it's worked out better for me than making one. The only issue with this is if you look inside there, I don't know how well you can see that, there's no thread in there. There should be a 1/4 20 UNC thread in that hole, and there isn't one. There is on this one, because that's how it fits onto the saddle itself. You can see it there, look, there it is. So I'll just have to make sure that that hole is the correct size for a 1/4 20 UNC, and then tap that. And also I think that small hole there, that's meant to run through and communicate with the threads inside for lubrication, to allow the oil to run down onto the threads, and that hasn't been bored all the way through, so I'll have to do that as well. But aside from that, it is a fantastic brand new or new old stock part. So I'll go on now to have a look at some of the other parts that I've detailed in some of the posts that I've put up. So you might have seen a while ago, maybe last week it was, or perhaps slightly earlier this week, I posted a photograph of some thrust bearings that I'd removed from the machine quite a while ago, and I just got round to cleaning them, and there was some false Brinelling on one of them that was quite drastic. Now, where those offending items came from, if we look at the diagram here, was the end of the X-axis lead screw, or the table lead screw. So these two items labelled up 57 are the two offending thrust bearings. And this is the keep here that these two bearings sit either side of. So what I'll show you now is, now that you've seen where these come from and what they're on, I'll show you the bearings and I'll show you the keep, how they're put together, and then we'll discuss the conclusions that we can draw from the damage that we see on the bearing. So this is one of the bearings we were just looking at on the illustrated parts breakdown, and this is an SKF 51101 open thrust bearing. So you might remember this from the posting that I mentioned before that I put on onto YouTube. Now this race is fine, and the ball cage is also in reasonably good condition. But let's have a look at this race. This is the race that was sitting facing the casting, or the bearing keep, and you can see on there's almost 180 degrees of false Brinelling. And I'll try and zoom in on that and get it to focus so you can see what we're looking at. There we go. You can see that much better now. And it's in a fair old state, I think you'll agree. It actually looks like someone's taken an engraving pen over it, doesn't it? Conchoidal striations, they're known as, that type of damage, that type of marking. And I believe that to be false Brinelling, which has been caused by... Obviously, the bearing contact area has been skewed to only so that the balls are only bearing against, or primarily bearing against this area here, and I believe that that's been caused by some sort of misalignment. And there's also been grease and grit and other dirt in there, which has, together with that misaligned contact, has allowed this fretting, or false Brinelling, if you like, to take place. And I'll show you now. I'll zoom back out, and I'll show you the keep casting, and I'll show you what I think's been going on. And you may already be drawing your own conclusions after seeing the diagram, the assembly diagram, or the exploded parts diagram. You may already be coming to your own conclusions about what the situation is. Okay, so this is the keep casting, which don't break it, Carl, which actually those bearings sit inside of and against. So we have the X-axis lead screw, plain portion, coming through this end, and then we have one thrust bearing sits against here like this, with the other race there, and then the other one sits inside this ball in there, and then we have a cover over this. The plain portion of the lead screw passes through here and has a nut on the end of it, which basically then keeps everything together, and then there's a cover over this part, and there's the nipple that was assiduously filled with grease over many years, and this whole assembly was completely covered in grease and hammerite, which I've now removed. And you can see the original Harrison grey there. This will need to be paint stripped further as well, and I'll repaint it. But anyway, it gives you an idea of how those bearings were assembled in the machine. So what I think has been happening is that let's just get the right one. Where is it? There it is. Okay, so in order for that to happen, then when this is assembled, if I exaggerate that, it must have been sitting like this. That is a massive exaggeration. Obviously, it would have probably looked like it was properly snugged up and properly aligned if you'd looked at it at a side glance. But it's been sitting in some way like that, or at least the loading has been like that, so that as this rotates, then this 180 degree area here is bearing all the load. And together with that and grease and other dirt that's formed a grinding paste, then it's caused this damage. So the conclusion that I've come to reluctantly is that the only way that that could happen, or one of the ways that that could happen, would be if the lead screw was bent, because then the sort of the cam action of the lead screw rotating, or kind of whiplashing or skipping, turning like a skipping rope, if you like, would be to cause that kind of wear pattern on that bearing. So what I'm going to do now is show you the X-axis lead screw assembly, and it's going to need some cleaning, and we'll strip it down and try and set it up and see if we can find out if it is indeed bent. Okay, so here we have the X-axis table lead screw assembly. Now this has been languishing in storage in the workshop for quite some time, since I took the table and the knee assembly off, and I haven't really looked at it or touched it. It's been just waiting for me to turn my attentions to it, and I've now turned my attentions to it somewhat more, shall we say, urgently, having seen the damage on that bearing. Now what we've got here, inside this keep, there is a kind of a dog clutch assembly, or affair, if you like, which helps to lock the lead screw to the machine for when we're using power feed. I'll show you what that's like on the drawing in a second, and then what we'll do after that is we'll get this thing cleaned up to some extent, anyway, a rough clean, and we'll get it disassembled, and then we'll try and get this lead screw set up so we can see if it is indeed bent in any way. So you'll have just seen me cleaning the X-axis lead screw assembly, because I just put out a little short as an adjunct to this video whenever this video goes out. So if you have a look at that, you'll see my somewhat primitive cleaning arrangements. But anyway, it's cleaned it to the extent that we can actually handle it now without getting completely covered in grease. Not a full clean, but just a rough clean, just so we can actually dismantle it without getting manky, and we can actually see what's going on with it. Because one of the things that I've had a problem with on this machine is that there's so much grease and dirt on it, you can't actually see what's happening. But before we do that, let's have a look at some of the documentation again. And this drawing is of the handle assembly and how it all goes together. So what we've got is, obviously we have the hand wheel here, and that is secured to this sleeve, which has almost like dog clutch teeth milled onto it, that you can see there. And this hand wheel can slide backwards and forwards on this portion of the lead screw, which is splined, and it's all held together by this nut on the end of the threaded bit here. We've also got a larger knurled nut here, which if we unscrew that, allows this handle assembly to slide back on these splines or to move forwards. And in the position it's shown in the drawing at the moment, this is for hand feed. So this clutch here is disengaged, and this clutch is formed by the teeth that are actually on this sliding and rotating sleeve, which is attached to the hand wheel, and a set of stationary teeth, if you like, which are fixed to the keep, which is, or this plate rather, which is bolted to the keep, and it's also held in place and located by this dowel pin here. So in the position it's in at the moment, fully forward, the handle can rotate and the lead screw can rotate. So by rotating the handle, rotate the lead screw, we then move the table, because the feed gearbox is attached to the table and the nut is inside the feed gearbox, and it's held captive by a worm drive. So when we rotate this, it moves the table. So when we want to use power feed, we unscrew this nut that allows the knurled nut rather, that allows the handle to pop back, helped by this spring here. That then engages these teeth with the stationary teeth, and that locks the lead screw to the machine itself, to the body of the machine, so that then when the power feed nut turns inside the gearbox, it moves the whole table and the power feed gearbox backwards and forwards along the lead screw. So what we'll do now is we'll actually have a look at this in the flesh, if you like, and we'll show you what's going on with it. Before I go, let me just show you, this is the this here is the index ring, and that is a grub screw with a spring and what they call a dog, which is basically a small brass disc. So that's pressing against this sleeve here, so that gives us a bit of friction, so we can rotate the index ring around and it'll stay where we put it. So much for the drawing. We'll have a look at the real thing now. So as I mentioned before, you may have seen my little short where I showed you my rather gruesome cleaning arrangements, but we've managed to clean it anyway, and it's clean enough for us to handle now and to see what's going on with it. So here's the lead screw, here's the handle, and there is the dogs that I spoke about that engage with the stationary dogs that are on the this plate, which fixes to the keep. And you can see here, look, the locating dowels and the two bolts that hold it in place, and the brass bush that the lead screw passes through. So that's how we can lock the lead screw to the machine when we're doing when we're using power feed. And you can see it's been Christmas, like it's in a roses box. The reason it's in there is because look at how that cleaner lifts this hammerite paint. It really does start to rip it off. So I put it in this Cadbury's Roses tub just to make sure that it doesn't get everywhere. Incidentally, by the way, I'm not sponsored by Cadbury's Roses or Cadbury's anything, but if they want to sponsor me, I'm certainly up for that. Never mind Banggood, Cadbury's can sponsor me, and I can do review videos about chocolates in the workshop. That would be good, wouldn't it? Anyway, you may have already noticed on the handle here something a little bit suspect. I'll just show you, as that's how the handle goes backwards and forwards. Look, there's the knurled nut that we spoke about, and what I suspect to be a metric nut that someone's rammed on the end of there, but never mind, we'll have a look at that in a second. So it looks to me like this hand wheel has been repaired by welding at some point in the past. Let's have a closer look at that. And somewhat roughly, it has to be said, I'll just show you some more evidence of that as we come round. You can see here, look, it's been welded up. So there's evidence of that on all three of the spokes. So I would say that that is a very bad sign indeed, because the only thing that's going to have broken that hand wheel is a lot of force, which has probably come from some sort of vehicular collision into the machine. Maybe a forklift truck or something like that has hit it, which doesn't bode well for my theory that the lead screw might be bent. Having said that, if we sight along, and I'll show you what I mean, if we sight along the lead screw, if I can get it to focus properly, which it might not do, but if we sight along the lead screw like that, it doesn't appear to be bent, if you can more or less see what I'm talking about. But we'll get this thing stripped down a bit further, and we'll try and take some measurements and see what like it is. So you can see what I'm doing, I hope, anyway. First thing to do is to get this nut off the end, which we'll do. It's a 9/16 spanner, so it was not a metric nut as I suspected. It is in fact a UNC nut. And there's horrible gunk coming off this as well, but that's to be expected. That's what I'm dealing with, everything I touch. Filthy. Right, so now we can get this knurled nut off. There she blows. And then the handle assembly should slip off the spline, which it has done. We'll get this stripped down a bit further because that spline sleeve should come off the handle. I think it's held on with a grub screw. So we'll have a look at that in a second. I'll bring you back for that. Right, so we'll get this handle assembly apart now. So we've got the spline sleeve, which is in the handle, held in by this what I suspect to be a 1/4 UNC grub screw here, and then it's keyed to the handle by this keyway here. So it means it comes out this way. So basically it'll come out in this direction, because these splines here don't key it to the handle as well. The little key in there, or that I just showed you, this one here, look, is what keys it to the handle itself. So we'll get this grub screw out, and we will proceed with getting the sleeve out. So I've got a 5/32 socketed Allen key, because actually I know this is a 1/4 UNC grub screw. So we'll get this grub screw out. And I've got my little plastic box here. Put my arm right across the shot there. Got my little plastic box for on bits. This does not anymore contain chicken tikka jalfrezi. It now contains bits of milling machine. Right, so that's that grub screw out. Let's reposition the camera so we can see the vise, and we'll get this apart. It's all live. Right, so let's get this. We'll spin around. Right, I have here, this is just out of shot. Actually, no, it's in shot. That makes a change, doesn't it? A piece of aluminium tubing. We'll put that aluminium tubing in the vise, thus. Now, if we sit that on there, we should be able, with a suitable socket, to knock that splined sleeve out of there. So a suitable socket would be this one, which is, what size is it? 3/4. There you go. Let's give it a little knock with my newest tapping stick. Yep, it's coming out. Put my hand under there so I can catch it. Yep, that's it. There it goes. There goes the socket. A certain person would use expletives. So there we are. Look, there's the spline sleeve with the key that we've just knocked out. So that can all go in the former receptacle for chicken tikka jalfrezi. And there's the hand wheel. And as you can see, it has indeed been repaired. All 3 of those spokes have been welded. And up here too, there's a weld. And also a sign of a crack there, look, where it's been damaged. So this handle has been smashed at some time in the past, and it's been welded back together again. And as I said earlier, I think the only thing that can have done that is a collision with a vehicle, or something heavy that moves. So probably been a forklift truck or something like that has driven into it. Right, let's have a look at the lead screw now. So before we look at the lead screw, I just want to get one more piece of disassembly out of the way, and that's the index ring. So this has 2 grub screws, one there, and they're 120 degrees apart from one another. And they bear against a spring, which then puts pressure on a little dog made out of brass, just a little brass disc really, and that bears against this inner splined sleeve, so that when this is actually attached onto the spline sleeve that goes onto the hand wheel, you can actually slide it around it to set your index ring where you want it, and then you can lock it. This has obviously been replaced. That grub screw is huge compared to that one, so someone's obviously damaged it or lost it, and they put this hoofing great big one in. So we'll take these out. What we expect to see in here is a spring. Just because we expect to see it doesn't mean to say that we're going to, though. And yet, as I said, as I expected, look at that. There's no spring in there. Try and get you to see if you can see that. No spring. But there is the dog. You can't see it very well. I'll show you it in a minute. So that means, hopefully, if we take this one out, there is a spring behind it. And it feels as if there is. Let's see. This thing just is the gift that keeps on giving. Yeah, so there we go. That's the grub screw out. Now, what it could be is that this one is so long because it's meant to lock it, so it doesn't have a spring. But on all the other index rings on this machine, they've been 120 degrees apart and they've had a spring, so I suspect that it's just got lost in the mists of time. Just give that a little bit of a wipe with a workshop wipe. There we go. On my fingers. Right, let's get a pair of tweezers and get that spring out of there. great thing about having a small workshop is that everything's to hand. Right, here we go. Let's get the spring out. Come on, you. Out you come. Yep. There we go. Very often you find these springs are kind of, they're engaged into the thread in a way. Right, there we go. That's one spring. We should have two, but we've got one. Never mind. Now, hopefully I can now push this spline sleeve out and the dogs should come out as well. Here it comes, yep. Okay, that's one spline sleeve. Let's give it a clean, or a rough clean. This is just a workshop wipe, just your wonder wipe type of thing. All right, that's that. Now we'll get the brass dogs out. Just use this little pick to push them out. Do they want to come out? Yeah, I think they will. Let's get a little punch. Talk amongst yourselves while I get a punch. Right, here we are. Just a little knock, I think, with the old tapping stick. Yeah, that's it out. So there's one brass dog covered in grease, as everything else is. That's what they look like. They just bear against the surface of this sleeve. Just stop it marking it and allow a bit of friction for it to rotate and stay put. That one's pretty marked up. Right, I'll get the other one out. Probably just fall out. There we go, that's it. That's another one. Right, so that's the index ring. We'll have a look at the lead screw now. Okay, so here's the lead screw. I've got it set up on the mill table. This is 3/4 inch by 6 TPI Acme, by the way. Now, before we go any further, I do not think it's bent. I think it's bowed. However, it's quite normal, I would think, for a lead screw to be bowed because it's relatively long and thin. A 3/4 inch Acme is about 1/2 inch core diameter, or well, slightly over. So I don't think it's bent per se. I think it is bowed. If we look at the damage on the hand wheel, the way that's been repaired and the way those spokes have broken, this is where it goes on this endlet where the spline is. I would suggest that that's been hit end on this way. So it's not had any impact to the lead screw that could have bent it. And the actual threaded portion is not going to have come to any grief anywhere. So if anything's going to be bent, it's going to be these at this end where the impact was. So we'll check it with the DTI. I happen to know what it is, and you can probably see I've written on there, but we'll bring you in and I'll show you what the deviation is, what the run out is, and then we'll do the opposite end. This is the only way I can do it really, because I can't get it between centers because the bed of my lathe is not big enough. I've done some other checks on it as well, which I will show you, and it all comes to the head that I don't think it's bent as such. But I'll bring you in and show you what the run out is on this end now. So I'm getting about 6 thou of run out on this end. I'll show you that now. I'll rotate the lead screw and you should be able to see the clock gauge. So maybe 6.5 there. Okay, and that's back to 0 there. So 6.5 thou, but I can look, I mean, just by slightly putting pressure on the lead screw, you know, I don't think this is anything really to worry about, because Obviously there's flex in it because of the reasons we mentioned. It's long and thin essentially, and under normal circumstances this is held in the keeps by, you know, bronze bushes. So when it's in position in the machine, then all the flex is taken out of it and it should be pushed into the orientation that it needs to be, and, you know, the level of straightness that it needs to be. So we'll check the other end now, and I'll show you that one. Right, so this is the end that goes into the keep with the two thrust bearings, and this has slightly more. It has about 14 thou, so I'll just show you that now. About 13.5. Hopefully you can see that there. So, yeah, what conclusions can we draw from that? Well, let's have a chat about it. So here's your discussion. So as you can see, before I put this lead screw on the milling machine table between V blocks and measured with the DTI, the run out at each end, I had it on this surface plate, which is the only one I've got. So it's not very big, but I've had to use it, and just rolled it backwards and forwards, just using a KISS approach basically initially. Keep it simple, stupid, because I am a bear of little brain. So just rolling it on here and rolling it on a flat surface on the bench, just intuitively, it doesn't appear to have run out. It's running true. And looking along or sighting along the section of the lead screw that's actually against the surface plate, I can't see light at any portion on this. And, you know, even if it was bent very slightly, I would eventually find it using that method, sighting along and looking for light. I've also had a straight edge up against the lead screw all along its length, and I can't really see anything discernible that indicates that it's bent. I do believe that it's bowed, but then all lead screws are bowed. It's a long, thin piece of steel basically, so it's going to have some bow in it. I mean, it's 40 inches long, and it's got a total indicated readout of, or run out rather, of about 19 thou. If we take the 6 thou and the 13 thou, then basically that's 19 thou over 40 inches on a shaft which is as long and slender as this. I don't think that's that bad actually, and you know, one would expect it to have some bow in it, and I actually think that this is perfectly serviceable, and when it's fitted in and it's gripped at both ends in its keeps, it will do the job it's designed to do. You know, they'll hold it straight basically and in the right orientation. So I've got no qualms about this actually being physically bent now. However, I do have another possible theory, or cause of the damage to these bearings, which I'll bring you in a bit closer, and we'll have a talk about that now. Okay, so what have we learned then? Well, this all started off with me trying to explain this curious wear pattern on this race of one of the thrust bearings from the lead screw. Now, we looked at the idea that the lead screw was bent. I've rejected that theory. I don't think it is. I think it's running as true as it needs to. And I think, yes, it's bowed, but all lead screws will have some bow in them. But I think from the point of view of being bent, it's fine. Now, that bearing runs in, or the lead screw rather, runs in this keep here. So one bearing is at the inboard end, which runs against this part of the lead screw. The other bearing is on the outboard end inside there. So on this machine, normally, anywhere where this is actually the old saddle lead screw, or y-axis lead screw if you like. Anywhere on this machine where a thrust bearing runs, this is a 51102 as opposed to a 51101, it sits against a shoulder like that, so that the load is evenly distributed around the circumference of the entire race, so that all of the bearing is taking the load essentially, and that's all specifically designed into every part of this machine that has a thrust bearing. There's always some kind of a shoulder for it to sit against, and that was just an illustration of that concept. But let's have a look at this lead screw. So I'll try and bring it a bit closer because I want you to see this. So, you know, I'm hoping to try and film this properly so that it illustrates my point. Obviously the lead screw is a thread, and you can see there, look, let's just bring you in a bit closer. And we'll just tilt down slightly, that's better. So the lead screw thread comes to an end here, and there's a little bit of a run out groove, and then you've got the plain portion that sits in the keep where the thrust bearings are. Now this race was actually at this end of the bearing, so if I put it on now, you can see what I'm talking about. This race was at this end of the lead screw rather, so for a start it's going to sit like that. It's not going to be on the nominal diameter. So straight away there's play there. And also, if you see, it's not, or the load is not being evenly distributed around the periphery of the bearing or the circumference of the bearing. So we have got a situation here that could quite easily have caused the damage that we see on this bearing. So we have the play, which is going to induce fretting anyway, and then we have, if we rotate this around, you can see the contact area there that portion of the thread has is, you know, it matches well with the damage area that we see on the race. So I believe that this damage, this false Brinelling, has been caused by this combination of these two phenomenon on the lead screw. The fact that we've got this run out groove here, so the thing is allowed to play. It's not sitting on the nominal diameter when this is fully engaged. And also the fact that, probably more importantly, the fact that the load is not evenly distributed around the surface of the race. And I believe that that is what has caused this wear pattern. So that's a good thing in a way, because at least it means my lead screw is not bent. But I may have to look into doing something to try and remedy that situation. Although, to be fair, you know, that's lasted 50 years. It's not great, but by the same token, it's not terrible either. So we might look at making some kind of a sleeve, maybe machine a bit of this back, and maybe Loctite some kind of a sleeve onto here, so that we've got, you know, good contact surface area on the bearing, and the load is evenly distributed through the entire surface area of the race. Perhaps we'll do something like that, but that's to be looked into in the future. So I will be replacing all of the thrust bearings in the machine. I'll be using Koyo because they are very good quality bearings made in Japan, and they come at a decent price. I buy them from Henderson's Bearings here in the UK, so decent quality bearings from a reputable supplier. I don't think you can go too far wrong with that. If you've just stumbled across me and you are new to this channel, please consider subscribing and give me a like. It really helps. And if you've been watching me for a while now, thank you very much for your continued support and patience, and welcome to all the new subscribers as well, because quite a few people have come along in the last few months. So welcome to the channel, and please stay tuned. So take care of yourselves, and I will see you next time.